So here I've got two multimeters. This one is set up to measure amps. It's flicked to the amp setting. So that's an ammeter. And this one, the plugs are in the right place to measure voltage. So this is our voltmeter. And what I'm going to do is I'm going to measure current and I'm going to measure the voltage at the same time. So the ammeter needs to be in a part of the circuit. In other words, current needs to flow through the ammeter. So I've got these two wires, right? That's broken that circuit open. And so I can take my leads and I can connect one here and one here. And that completes my circuit, right? Current's flowing through my ammeter, and you can see that both the power supply and the ammeter are showing there's current flowing. Now you might very well think, why do I need to use an ammeter when the power supply tells me the current anyway? Yeah, really good observation. It's because later on we'll do more complicated circuits where you'll need to measure current through different pathways, and that will not be the same as the current on the power supply. So you need to know how to use this, even though we could just cheat and use the current here. And the next thing we want to do is we want to measure, and what does this say? The first thing is measure the voltage across both resistors. In other words, what is the potential difference between this point, so above R1, and this point below R2? So to do that, right, take your voltmeter and clip it to one side of the resistor. It really doesn't matter where, right, as long as it's on this leg of the resistor. And then take the black one and clip it over here. And what we can see, we've got 5.97 volts dropped across both resistors. So the voltage, or the potential difference across both resistors, is 5.97 volts. So we can measure that. 5.97 volts. Right. And then the next page, it asks, okay, what is the voltage across just R1? What's the voltage across R2? So to measure the voltage across R1, we're going to disconnect this black lead, right? And we're going to connect it to this leg of R1, and we get 2.96 volts. Now, we could also connect it to this point here. I know that's the leg of another resistor, but like there's very little resistance between this point and this point. This is just like the wires connected to the resistor. The resistory goodness is in this ceramic chunk. So there's not a huge difference between measuring on this leg and measuring on this leg, because we're still measuring the voltage between from one side of the resistor to the other side of the resistor, even if we haven't clicked this other one. If that doesn't make perfect sense right now, don't worry, you'll figure it out as we go along. So you click that there, right? 2.97 volts. So write that down, 2.97 volts. And then to measure the voltage across the second resistor, R2, just move your legs so that they're on either side of R2, and we can measure the voltage across that resistor. So 2.98. Now there is another circuit which asks you to do 3 resistors, but I reckon you can probably figure that out on your own. Cool. Good luck with that.